Assalamualaikum and good morning to Dr. Shoket and everyone. Today our group will be presenting analysis and characterization of petroleum product, which is kerosene. Kerosene is a flammable hydrocarbon liquid widely utilized as a fuel source derived from the fractional distillation of petroleum. Kerosene, also known as a kerosene, paraffin oil, fuel oil number one, or lamp oil, which serve as a significant fuel for household, commercial, and industrial applications. Kerosene serves as a combustible fuel in kerosene lamps, household heaters, and furnace, primary or supplementary fuel in jet engines, and act as an effective solvent for greases and insecticides. This kerosene derived from the fractional distillation of petroleum oil involving process of separations, purification, and extraction. Kerosene is a flammable hydrocarbon liquid widely utilized as a fuel source derived from the fractional distillation of petroleum. Kerosene, also known as a kerosene, paraffin oil, fuel oil number one, or lamp oil, which serve as a significant fuel for household, commercial, and industrial applications. Kerosene serves as a combustible fuel in kerosene lamps, household heaters, and furnace. Primary.
For the characteristics of kerosene, kerosene is a pale yellow or colorless liquid with low viscosity. It has a mild, distinct smell. Its density is about 0.78 to 0.81 gram per centimeter cubic, and it boils between 150 to 275 degrees Celsius. The flash point is 37 to 65 degrees Celsius, and it can freeze as low as negative 47 degrees Celsius depending on the grade. Kerosene ignites at around 220 degrees Celsius and provides high energy, about 43 megajoule per kilogram. It mixes well with petroleum solvents but not with water. It is made up of hydrocarbons with 6 to 20 carbon atoms, and it comes in two main grades. 1K for cleaner use and 2K for kerosene contains more sulfur and impurities. Next, for the application. First, kerosene is used as a lighting and a heater fuel in developing countries where electricity source is expensive, inconsistent, and unavailable.
Kerosene is widely used in portable stove and heaters for cooking and space heating, especially in regions without access to natural gas or electricity. Kerosene stove using wicks rely on a cotton or fiberglass wick to draw kerosene from a fuel reservoir to the burner head. The wick is ignited to produce a controlled flame with heat output adjusted by raising or lowering the wick. The flame heats cookware such as pot or pan placed above the burner.
Gas chromatography and mass spectrometry (GCMS) are used to determine and characterize the chemical components present in a kerosene sample. It is also used for qualitative analysis that can provide high sensitivity and selectivity. GCMS is effective for volatile, low polarity, and thermally stable compound, and it uses capillary column that can produce a large number of peaks. Target compounds that can be found in the kerosene sample are aromatic hydrocarbon, alkane, and cycloalkane, typically with carbon number from C6 to C16. For kerosene preparation, 0.5 ml of kerosene was diluted with 19.5 ml of methane.
This is the result that shows the peak about the component that contained in the kerosene by using GCMS. Kerosenes contain a complex mixture of compounds, such as volatile and semi-volatile hydrocarbon. There were 50 amount of compounds that found during the analysis. The most abundant compound was heptane, 5-ethyl-2-methyl, with the area of 11%. The other major alkanes detected, such as octadecane, at 7.17%, dodecane 2,6,11-trimethyl with the percentage of area of 5.41%, decane 3,6-dimethyl and 4.10% of the area. These all average or long chain X is the presence of aromatic hydrocarbons such as mesethylene, naphthalene, and also methyl derivative, which then they contribute to energy density, stability, odor, and also emissions. The presence of minor components such as ester, like butyric acid, 2-pentyl, then 2-U ester, and also hydrochloric acid isohexyester was maybe originate from the additive or degradations, which then influence the storage stability. Next is about high confidence in the edifications, whereby mostly they are scores above 85%. The exceptions for the low confidence compound, such as 2-isopropyl 5-methylic 4-NL at peak of 23, shows the lowest confidence, which then it is requiring for further confirmation.
For this study, we used FTIR spectroscopy to characterize the kerosene sample by identifying its molecular structure and functional groups. FTIR works by measuring how molecules absorb infrared light, revealing their unique vibration pattern. It's a fast non-destructive technique and highly effective for detecting both organic and inorganic compounds. We use techniques like FTIR to observe specific peak, particularly CH stretching around 2950 to 2850 per centimeter and bending around 720 per centimeter, which are strong indicator of long-chain alkene commonly found in hydrocarbon mixture like kerosene. The FTIR results show peaks typical of aliphatic hydrocarbons.
From our FTIR result, it is clear that the kerosene sample is made up of long-chain saturated hydrocarbons. We saw strong peaks around 2954, 2921, and 2853 per centimeter, which are typical of CH stretching in methyl and methylene groups, confirming the presence of stretch-chain alkane. And we also observed CH bending at 1456 and 1377 per centimeter, supporting the presence of these same groups that are and hinting at possible branching. And one of the peak at 721 per centimeter is linked to CH2 rocking, which tells us the sample is likely contain linear alkane with 4 or more methylene group units. And we also detected some minor peaks between 697 and 781 per centimeter, and this suggests that there's a small amount of aromatic or branch compound, which also fits with our GCMS data. And lastly, we did not see any peak around 1640 to 1680 or above 3000 per centimeter, which would indicate alkene. So we can confidently say that the sample contains no unsaturated hydrocarbons.